Hello everyone, welcome back to my channel. I hope you are enjoying my videos. Today I am going to talk about the parallelism in .NET using async operators. So you heard about async and await. When you write a program to go for asynchronous, we used async await operators. Async for method and await for async methods. But what happens if you wanted to list of independent async operators that you want to run simultaneously? So right, synchronization is executed by one, but if you use async and if you wanted to run parallelly multiple things at a time, so how we are going to achieve that? So that I'm going to talk about that right now. So in Word we have parallel dot for each. It is a great CPU bound task, but it struggles with asynchronous I/O output scenarios. It is a CPU bound, so it won't have that I/O input output asynchronous way. But .NET 6 and onwards, there is a game changer called Parallel.ForEachAsync. Using this, we are going to call parallel tasks simultaneously. So anyhow we will break down what it is and why you need it, and I will give you a clean and practical example to implement it today. Let's dive in and let's look into one common scenario. Here I am showing we have a list of URLs. So I have the list of URLs here. We need to fetch data from each URL. In traditional way, it's look like this. So I have the list of URLs and I have HTTP client I have declared, and I just wanted to see how much time taking for to complete the all, and I'm looping those URLs, I'm calling and I'm getting the data. This is the traditional way. In this code we make one web request and we are doing one web request, so it's going to come one by one and wait to finish this and then make the next one. So it is going to call the one request and complete and go for next one. Suppose each request, if you imagine, takes 2 seconds to complete this list, it's take around 6 seconds. So right, that is slow and inefficient for input output bound work. So this is where the parallel dot for each async shines. Actually, it was introduced especially to handle asynchronous delegate concurrently. Concurrently means at a time it's going to call. So it won't wait for to complete one request. So it's going to send all requests at a time parallelly. So it will handle parallel execution and it gets output. Suppose let's imagine. So at present to complete this request takes 6 seconds. So if we use parallel dot for each async, totally it takes only 2 seconds. That's beauty of parallel dot for each async. It is incredibly simple. Actually, it is incredibly simple to use. Previously, there is other ways we can achieve same. I mean, .NET framework and before .NET 6. But now parallel dot for each async is incredibly simple to use. We provide our data source. Actually, we provide our data source here. The body of the async works using lambda expression and optionally parallel or option object to control the degree of parallelism actually. So I will come to know what is the parallel option object parallelism. So as I mentioned, it's parallelly execute, it won't execute one by one. So the much more faster, and we are going to utilize the CPU usage more. And let's give the example now. So let's refactor our previous example using parallel dot for each async. So this is my refactor code. So I have a list of URLs, bunch of URLs here now. I have the parallel async downloads. This is the method. So it's going to execute parallelism. If you see that I use async and task, so it is going to support asynchronously. And if you see that this is await. So and as well as I also used parallel.ForEach. Let's go into one by one. First, we define the parallel options. This is the I had defined the parallel option. Set the maximum degree of parallelism to 4. So what is it is meaning is, so at a time it's going to send four requests in parallel way. Without instead of sending all the this list at a time, it's going to set we can set the degree of parallelism, max degree. So each request it's going to send four parallel calls. So that we are going to set it by the parallel options. That is the first step. So that's I have provided for each async. Next, the parallel dot for each async. So this is parallel dot for each async method. It takes a collection of URLs. So this is the source I am sending. This is a collection of URLs and lambda function that is async. So I also passed the degree of parallelism and this is the method I am passing to execute. So these three parameters is required. So inside the lambda, we use await as we normally would. So this is async. This is async that I have provided await, and that the TPL scheduler manages to reset and especially switching between task and await IO operations. Task parallelism. So this is we used to call TPL task parallelism. So it's going to schedule manages the rest. So it's going TPL is going to schedule and it manages automatically switching between the tasks as they wait IO operations. So this is we can call it as a TPL task parallelism. So it's going to handle for us. So as I mentioned, it's very simple. In previous, we have to write manually all this kind of how to handle parallelism. Now we have a simple method. We just need to pass the source and the degree of parallelism and async method. So the rest is going to be taken care. So you see that how easy it is. So when we run this, we see the output is no longer is sequential. So it's no longer in sequential. It's no longer execute one by one. Request 1, 3 and 5 might finish before 2 and 4. The total execution time is drops drastically from 6 seconds down to roughly 2 to 3 seconds. Since this works parallelly, the significant waiting time can reduce, right? So instead of 6 minutes, 6 seconds, it's going to complete by 3 seconds. So the usage of CPU is much more less now because of input output bound. This is power of parallel synchronization, asynchronization execution. This is called so you know how it is, right? How easy it is. So parallel.forEachAsync is an essential tool for modern .NET developers. So all modern nowadays we are going to use parallel.forEachAsync. Use it normally whenever you have a collection of independent IO bound tasks like making API calls, reading, writing files, and hitting database. So most of the scenarios, so it's mostly useful. So we most of the scenario we are going to call APIs and calling database and reading, writing files. So all these scenarios we can use this method parallel for each async. So I'm going to give some more alternatives for this. So most of the scenarios I have mentioned the input output bound. So what exactly it is? So input output bound refers to a condition where a total time taken to complete a task is limited primarily by the speed of input output operations rather than speed of CPU, central processing unit. So what is suppose let's imagine one thread comes here. So this is my parallel. One thread comes here, and let's imagine this taking data from this APIs takes time. So what here it is so instead of the thread waiting to complete here, the thread is going to continue processing remaining one until the request comes and the output comes to here. It keeps continuing. So previously it's not a CPU bound. I mean, it's not central processing unit bound. So in central processing unit bound, it still wait here to complete. So let's imagine it takes a lot of time to complete. The CPU usage will get increased, right? Because it's still waiting to complete. But as part of output, it issue a thread here, and since this is taking time, instead of waiting, it start continuing other one. So the waiting time going to drastically decrease, and we are not utilizing CPU memory. So this called input output bound. So this is the simple example. The CPU initiates the request, then goes to idle or switches to another task. The majority of the time here is spent waiting for the network hardware. So CPU waiting, so this is the IO input output way. So there is no, we are not waiting for CPU usage here. So this is, so what is the CPU is, so CPU bound code example is, this is CPU bound code example. CPU is constantly performing arithmetic operations. So it is 100% busy for the duration of the sleep. So here we are looping run the billions of trillions of times, forcing CPU to work hard. So here we are asking CPU, the thread is going to continue working here. So CPU usage is going to be increased now. This is just CPU bound example. This is simple example, but using task dot parallel, parallelism. So parallel dot for each async is going to be, handle that way. It is a input output bound. So it is user less CPU memories and timing. So it's going to call parallel task and improve the performance. So we have some, as I mentioned, we have some alternative also for the parallel dot for each async. It is SemaphoreSlim. So we used to older .NET versions. So we have to write our own code to do the parallelism, and as well as we action block. So the means semaphore slim complexity is medium, and we have to write manual control for that. And action blocks, there is another alternative. So these are the alternatives. So if you see, these are the alternatives. I think it is not coming here. So let me go. So these are the alternatives. One of the alternatives, semaphore slim. This complexity high, we have to write the code like this. So you see that sim for wait async, and so this is the pre.NET 6. There is a, I mean, so I have to write. So it's going to, here the one more issue is it's going to issue all the all request for. This is the manual way. And if you see one more alternative, Task.WhenAll. So here we can't control how many issues we need to set. No throttling here because all tasks fire at once. It's very simple, but it's all tasks fire at once. Suppose we have 100 tasks, so it's going to issue all 100 tasks one at a time. So our servers could be busy. So we should not use very in that scenario. This one, there is a semaphore slim. We have to write manually. And summary, these are the summary. So parallel dot for each async limit, so we can set limit how many issues, how many requests we can send at a time. Complexity low, best for modern, so modern .NET, all this we should use this. And semaphore is the custom control and legacy. For legacy where we are working .NET framework, we can use this. And task.when is a small list. If you have a list of 5 to 10, we can use this. So task.WhenAll. I hope you understand how easy we can achieve async parallelism in .NET, and I hope you understand this concept very well. If you need anything, please let me know and message me and like me, like my video and share to your friends and family. Thank you guys. Please subscribe. Thank you very much.